Hello, everyone. Thank you all for joining, and welcome to what I hope will be an informative and useful presentation on how to leverage modeling and simulation to improve how you define and design your facilities going forward. Before I get started, by way of introduction, I'm Michael Verdier, and I lead the integrated industrial design market here at BHDP. The integrated industrial design market focuses on owners that have manufacturing, warehousing, and distribution facilities. Excuse me. And I'm here with Sam Zhang. Sam has a background in business logistics and engineering, and Sam leads the supply network operations and analyst group here at BHDP, primarily doing our modeling and simulation work across each of the markets that BHDP serves. Before we get started, I just want to say a couple things about why we think leveraging modeling and simulation in planning and design is important. What I've been observing and have experienced firsthand is that for owners making significant investments in their facilities and operations, it's simply no longer feasible or acceptable to invest significant numbers of their own resources, their capital dollars, and time defining facility requirements in some of the traditional approaches. And what I mean by traditional approaches is that shifting away from using historical norms or local preferences where they're operating, things like, well, this is how we've always done it, rules of thumb, or even static Excel spreadsheets. Owners are now requiring database solutions that include modeling and simulation as an integral part of their facility planning, definition, and design process. With that, I'm going to turn it over to Sam to begin sharing more details of modeling and simulation and demonstrating how we've used this to optimize throughput in a biomedical research facility lab. And not to say that you can't use it in lots of other facilities, like manufacturing, warehousing, distribution, workplace environments, but this is the example today that we've elected to share. So with that, I'll turn it over to Sam. Thank you.
Okay, thank you, Michael. So let's start with a question, actually. So how many of you have experience in modeling simulation, and how would you characterize your current experience of utilizing modeling simulation tools for facility planning and design? So you should see there are 4 options on your screen right now. So fundamental, practitioner, expert, or none. So I will give you 5 seconds to submit the question. So, okay, so looks like most of you have already some experience in modeling simulation. So I will go this part really quickly. What is modeling simulation? So a simulation model is a realistic virtual representation of an existing or planned system. And the next, we're going to talk about what are the benefits of integrating modeling simulation in facility planning and design. Things like synchronizing facility to production, capacity demand, analyzing people, product, and truck flows, sensitivity analysis of process and equipment changes. So next, I would like to use a real example to demonstrate how we leverage modeling simulation in facility planning and design. In this project, the biggest challenge we trying to solve is to identify bottlenecks in current system so that we could come up with alternative plans with maximum total throughput and minimum cost. In order to make sure we fully understand the whole system, we usually will create a process flow diagram before building models like this one here. As you can see, we use 2 different colors to differentiate whether an item is clean or dirty. So in this process flow diagram, brown means dirty and green means clean. The items involved in this project are ranks, cages, carts with cages, and empty carts. The machines here are autoclaves, or the picture you can see here. Rank wash, tunnel wash here. So the process is dirty carts with cages and dirty ranks come from the animal holding room. They will go through the process, and dirty cages go to the dump station and then the tunnel wash. And dirty carts and dirty ranks will go through the rank wash. After they all cleaned, we put the clean carts and cages together and then go through the autoclave as well as the clean ranks. So next, I'm gonna jump into the model and show you how we made all this happen in modern simulation.
Yeah, I just want to say, I know maybe not everyone is familiar with the biomedical research facility. What this process flow diagram is that Sam is showing, and we would do this for every project, is this is the ground level of a 6-story facility, and it's obviously a research facility, and there are different protocols for cleaning depending on what research is going on. So in this facility, there could be anywhere from 10 to 20 different types of research programs occurring at the same time. Each of those have a different protocol for cleaning the cages, sanitizing the cages at different frequencies. So some may require the cleaning to occur every day. Some may require it to occur, every 2 or 3 days. Cages are different sizes, but the problem that we were trying to solve here was the owner wanted to increase throughput. And so we were really trying to evaluate how could they increase the throughput of the cleaning process, so the cage washing, the sanitization, at the lowest capital cost and operating cost going forward, but also increasing ongoing profits. And so those are the scenarios or alternatives that we evaluated using modeling and simulation. So I think that's just to give a little bit more background on what the biomedical research lab is. We're only modeling the ground level of this. We could have easily modeled all 6 floors, but this is really where all the operations are occurring.
And by the way, if you guys have any questions, you can use the function on the bottom. It's called Q&A, so it should be on the bottom right side. So if you have any questions, you can submit the questions, and we will be able to answer some of the questions at the end of the presentation. So I think you guys should be able to see the model right now. So as Michael said, this is the just ground level of the research facility. We actually built this model based on the process flow diagram I just showed you. Plus, we imported the CAD file as background. If you still remember, the major objectives of this model we are trying to solve try to validate the current design option, identify bottlenecks, and maximize throughput with less capital cost. And in this model, we actually use red to represent dirty and white to represent clean. So I just let the model run for you so you can see the red ranks, which is dirty, coming from the animal holding room, and it will go to the rank wash, and the dirty red carts with cages coming from the animal holding room 2 will first go to the dump station, and then got separated. The dirty cages will go through the tunnel wash, and the carts will go through the rank wash.
I just want to say something else about the process flow diagram. If there's an existing facility or even new that you're planning, I think a key validation step is to always produce a process flow diagram. We make sure that we've completely understood all the inputs and outputs. We've understood the speeds of each of the operations or their current throughputs. We also make sure that we understand what their failure modes are, so mean time to failure or mean time to repair. So in any project, process flow diagram is critical to making sure that we've captured the processes accurately. We review those with the owners or the client, and it's a key validation step in any of the projects. And then obviously the visualization of actually getting it into modeling and simulation, as you see here, as Sam's demonstrating. Then we can also observe and make sure that it's operating, if it's an existing facility, as it is today. Another validation point. And so, go ahead, Sam.
Yeah. So you can say the cars cages are cleaned. So we have an operator to assemble them, put them together, and then go through the autoclave. And the same thing for the ranks. After they are cleaned from the rank wash, they will be sent to the autoclave.
Autoclave is where the real sterilization is happening before the cages are available to be sent back into any of the research labs.
Mm-hmm, yes. And also based on the data we collect, we assign a process time to each machine, like the rat wash here. So it can process at most 2 items at the same time as the maximum content. And it takes about 10 to 13 minutes to clean one item. And what's more, we can add more details to make the model as accurate as the real operation. Like in this case, we know we have 2 barrels in the dump station, and each barrel can dump in 36 dirty cages. So after both banks are full, the operator needs to take them to the short-term waste store and put new banks in the barrel. So I will just let the model speed up and run, say, for a month. And in the meantime, we can actually pull out the dashboard. So while the model is running, we can actually see a lot of, maybe there's
a little bit of delay, so yeah. There's the dashboard.
Okay. Sorry about that. So I think you can see the dashboard now. So while the model is running, we can actually get some of the data, like the utilization rate for each of the machines, throughput for each of the machines, like traveling distance for all the operators, and so on. So in the dashboard, you can see all the autoclaves are very highly utilized, almost 100%. While the other machines like the tunnel wash, rank wash are very light utilized. So that's the current bottleneck. So in order to fix that, we came up with 2 alternative options. We named that option 1 and 2.
So I just want to say something here. This is reality. This is what the owner was experiencing. The autoclaves were the bottleneck. They felt like they needed to spend capital dollars on additional autoclaves. But we weren't convinced that that was really the optimal solution. So what are some of the other scenarios or possibilities to help reduce overall capital spending for them? And so these are the two scenarios that we looked at. There was many that we looked at, but there's two that Sam will show.
Yeah, this is actually option one. So we increase the number of autoclave from 2 to 4 in this option, and we keep the rest of the model the same as option base. And here comes option 2. It may take a second to show up in your screen. Yeah, so you should be able to see option 2 right now. In option 2, we still keep 2 autoclaves, but we actually increase working hours for the autoclave related operations. It may take a second to show up in your screen the new schedule. Yeah, so we add a second shift for autoclaves and 2 operators who operate for the autoclaves. As you can see, we can define all the working hours and break hours for the machine and operators.
They're able to see it now.
Okay.
So I think there's a lot of things that you can do that you can't do in a static analysis or Excel spreadsheet in real modeling and simulation. I mean, you can really make this as it is as you operate. I mean, whether it's schedules, failure modes on equipment, you can really start to do sensitivity analysis of if you increase throughput on one piece of equipment, what happens downstream or upstream. And that's really what we're doing here. It's very difficult to do that in Excel spreadsheets or static type analysis, whereas more of the dynamic analysis lends itself to uncovering what's really happening in an operation as you make modifications.
Actually, in option 2, the thing I want to mention is what it can solve the question is it will build inventories in the first shift in front of the autoclave, but all the inventories will be able to consume in the second shift. So also we need to find some space for short-term storage in option 2, and we let model run for option 2 and 1 the same amount of time as option base, which is a month, and we look at the dashboard again. We can say we are able to increase the utilization rate for tunnel wash and rank wash, but still we keep very highly utilized for the autoclaves. That's option 2. And I just pull out the dashboard for option 1, but it may take a second to show up in your screen. Yeah, you should be able to see that now. So pretty much the same thing. We increase the utilization rate for tunnel wash and rank wash, but still keep all the autoclaves very busy. So next, I would like to have a closer look at the data for all 3 options. Okay. From option base to option 1, we increase the number of autoclaves from 2 to 4. From option base to option 2, we keep the number of autoclaves the same, but we increase the working hours from 1 shift 8 hours to 2 shifts, and 6 hours for each shift, and keep the rest of the model the same.
I just want to say something here. So you can see that the base condition is really 2 autoclaves. You've got 5 operators running that entire operation. Option 1, there was capital costs associated with the 2 additional autoclaves, but also there was space within the facility that had to be reprogrammed. So there was facility changes or modifications that had to occur. If you look at option 2, there was no new equipment required. We wanted to just see what would happen if we just added 2 operators on basically a second shift. And I think what's really unique, what's really important there is you can see that the base option, in 1 year, the throughput was about 3.8 million units. Option 1, about 6.3, with two additional autoclaves and facility modifications. But just by adding 2 shifts, no new equipment, you could get that same almost doubling the throughput through that operation.
And if we look at the values we can get from developing 2 alternative options, so for 1 year of time, we almost double the total profit from 788,000 for option base to 1.5 million for option 1, and we even get more for option 2, which is 1.9 million.
And this is taking into account incremental capital cost, incremental operating cost in each of those. So this is really net profit.
And we also did some further study about the break-even point for option 1 and 2, which is about 12 years. You can say in 12 years of time, they are about the same. But you need to keep in mind that we purchased 2 more autoclave, which means more capital cost in the first several years for option 1. So if the depreciation period of autoclave is more than 12 years, option 1 is better. But if it's less than 12 years, option 2 is your best choice.
And I think most businesses won't want to wait for 12 years for a payback. So in this case, the recommended option was option 2, to add the shifts. No new capital equipment purchase, no modifications to the facility.
And actually, in fact, we could compare as many options as you want to in a relatively shorter period of time and with less cost. Besides changing the number of machines and working schedules, we could also compare different layout designs, machine speed, location of equipment, production and storage strategies, and so on. So based on all this information, decision makers can easily and quickly compare different options and make an optimal decision.
Yeah, I think as you look at modeling and simulation, we use it as yet another tool in how we do planning and design. It's not always appropriate to use modeling and simulation. There are times when Excel spreadsheets of very simple operations might be the right tool. But for complex operations where there's a lot of, sensitivity to upstream or downstream operations, modeling simulation really uncovers some of the unexpected things that you may not have anticipated. And one of the other things I'd say is what modeling simulation has helped us do is avoid overbuilding or underbuilding in some of the facilities that we've been planning. And overbuilding or underbuilding each have equally negative consequences. So overbuilding, in our case, if we had to put in 2 autoclaves, it can lead to excess capital spending, longer schedule durations, increased depreciation cost, and overall higher TDC or total direct cost of the services or products that you're providing. On the same note, underbuilding could be just as catastrophic to a business, resulting in an inability to ship the business if you're producing products. Could be higher transportation, warehousing costs. If you have to do interplanting or import product because you can't produce to meet the market needs, loss of market share. So again, the modeling simulation is a great tool It's not always the right tool, but we found that it has really given us the ability to deliver database solutions for complex problems. And I think with that, if you've got some questions, we're happy to take those. I think, as Sam said, there's a Q&A button at the bottom of the screen there, and we've got a couple of questions already we'll try to answer before we close. One question we've got from Peter is, what software are we using? We're using a software called FlexSim, and why do we use it? We are a design firm. We're a very visual firm using Revit, AutoCAD, and so we wanted the ability to pull in the backgrounds of our designs and actually, to scale, lay out the equipment onto our conceptual designs, if you will. As I said earlier, it allows us to do validation, and it allows us to make modifications to layouts, what I would call general arrangements of equipment, and then those are reflected back into the design. The other reason we selected FlexSim, and we did a couple years ago before we invested in this, we cast the net very wide in the evaluation of applications. We wanted something that we could use in all the markets we serve. So whether it's in the industrial market, our workplace market, our retail market, our science market, as this demonstration was, it had that flexibility. We've used it in manufacturing operations, in the planning process and in the design process to define how large a warehouse should be, the rack layouts, the types of racks, where fork truck circulation doors should be, or even the number of dock doors. So that's how we've tried to leverage modeling and simulation in the industrial market. We've even done it for logistics park, for a large automotive manufacturing supplier. So one of the other nice things about FlexSim is it allows us to import. It's very unique in that it allows us to import warehouse management data, yard management data. So if we're working with a customer that has that, we can pull that into the model, and we get that base information in order to establish what's the base operation, do that initial validation before we start to look at optimization. And in that case, it would be if it's an existing facility. So FlexSim is a real powerhouse as opposed to some of the other applications that we evaluated. Very visual. It's great for leadership if you are doing reviews with, say, general managers, vice presidents on options or alternatives, and it's great for validation. So long answer, but FlexSim is the application we're using. Got another question here. If you don't have information on production throughput, line speeds, failure modes, how would we begin to develop a simulation model that represents an existing or new facility? Well, one of the ways we can do that is contacting directly your equipment supplier. So typically they will have what the throughput speeds are of their equipment. It's usually a range. That's the other nice thing about FlexSim. We can create statistical distributions on speeds. Everything's not always going to operate at 1,000 units per minute. There's going to be statistical distributions in that, as well as the failure modes that we talked about. But we can usually get that from equipment suppliers, so OEMs. Everything from the throughput to the failure modes that I talked about, we can get the equipment footprints from them. If that's not a possibility, we've also gone out and done time studies. We actually had to do that on the logistics park that we planned. So either from the original equipment vendor or doing time studies of existing operations or operations that will be similar if you're planning a new facility. A couple other questions here. So here's one. Within an existing production facility, is it necessary to model the entire operation to evaluate and analyze the impact of a production change. And I'd say not necessarily. You can leverage modeling and simulation to simulate only the operations and facility spaces you believe are directly impacted by a module or a group of modules. So for instance, if you wanted to understand the impact a speed-up initiative might have on, I'll just use dock utilization or staging area requirements, you could model just these isolated areas as part of an overall model development. We've used this to evaluate optimizing equipment general arrangements for very highly manual packing operations to optimize finished product throughput and packing team productivity. Even just, I guess it was last week, something as simple as a cafeteria dining checkout operation that was being renovated. We used it for that. We didn't model the entire dining area, but just the checkout operations, how the food cases and cashiers and the flows would happen there. So optimizing that to make sure there weren't bottlenecks inside that. So no, it's not necessary to model the entire facility, although we could. So I hope that answers the question. Yeah. And I think that's it. I think that was all the questions we had. So with that, I hope that this at least gives you some insight in how leveraging modeling simulation could benefit your overall facility planning and design process, whether it's an existing facility that you're expanding, a new facility. Leveraging modeling simulation might be a tool that allows you to bring robust database solutions to your project. And with that, I thank you very much for joining today. If there's other questions, I think in the registration you have Sam's contact details and my contact details. And of course, you could also always go to BHDP Architecture's website and reach out to us that way. Thank you very much. We'll be giving other webinars in the coming months. The next one I think is on parametrics. Very interesting topic or technology that we use within BHDP. Really compresses the overall conceptual planning for the projects. So if you haven't heard about parametrics, look it up or join us. Invitations for that should be coming out in a week or so. With that, thank you very much and have a great afternoon. Bye now.